Alright, hello everyone, welcome to my channel today. I'll be looking at some likely ETME questions because of the ETME students. Their exams are very close, less than 16 days time. So I'll be looking at possible questions, how they are rampant in the past questions, the areas of concentration. I also refer back to the mock questions, what they tested them during the mock examination. That's for the ETME. Now for this video, it will be useful for students writing ETME, not for them just cramming the questions into the exam. Also looking at the analysis, because these areas came out in the mock, they are likely to come out in the main exam. I'm not saying it will, but these areas are important and vital areas. They are crucial areas to the exam. So I'll dive into the question one very fast. It's going to be a series of 40 questions, 40 likely questions with analysis. Most importantly, get the analysis. Question one says, what is the temperature of a gas initially at 17 degrees Celsius and 12 atm if the pressure increases to 36 atm? Now, if you are faced with a question like this in the examination, now first of all, reading the question shows it's a calculation question. Said, what is the temperature of a gas? So that means I'm going back to gas laws, kinetic theory of matter, gas laws, initially at 17 degrees Celsius. So a gas was at 17 degrees Celsius and 12 atm, exactly. And if the pressure was increased, so which law are we going to look at here? Now, these are under gas laws. There are some certain gas laws. I listed them. There was the first one, Boyle's law of Robert Boyle, Charles' law, Charles, which was later called Gay-Lussac's law, refined by Gay-Lussac's. Then Guillaume Hamilton's law. Then we have another one which is also very important for the examination, Graham's law of diffusion. Now, what did Boyle's law state? So quickly, Boyle's law states that pressure is inversely proportional to volume, provided temperature remains constant. So I'll quickly dive into it. For Boyle's law, P1 V1 is equals to P2 V2. Now, for Charles' law says at constant pressure, volume is directly proportional to temperature. That means for Charles' law, V1 over T1 is equals to V2 over T2. Charles' law. So when you are giving questions on Charles' law, I'll show you how it looks like. Then we'll use this. For Hamilton's law, very uncommon. Now, Hamilton's law is more like Charles' law, but this time he said that constant volume pressure is directly proportional to temperature. That is P1 over T1 is equals to P2 over T2. Then Graham's law of diffusion. What did Graham's law of diffusion state? What did the law state? The law states that it's either called the Graham's law of diffusion or the Graham's law of effusion. Diffusion is the movement of molecules from a region of higher concentration to a region of lower concentration. So we are looking at diffusion in gases because gas laws. You get me? So quickly, Graham's law of diffusion or effusion. So diffusion of gases through a tiny hole is called effusion. Now, what did Graham's law say? Graham's law of diffusion or effusion states that the rate of diffusion of a gas is inversely proportional to the square root of its vapor density. The rate of diffusion of a gas is inversely proportional to the square root of its vapor density. So going from that, I can quickly put a law forward, or I can put an equation forward. That means that for Graham's law of diffusion, I'll just save time. What I give my students, because it's not a video on Graham's law, I have to solve this question. Now, when I give my students, for Graham's law of diffusion, I'll say they should use this. R1 over R2 is equal to V1 C2 over what now? V2 T1 equal to square root of molecular mass 2 over molecular mass 1, where vapor density times 2 is equal to molecular mass. So mm stands for molecular mass, T here stands for time. So it means that rate is inversely proportional to time. V here stands for volume. V, volume. This is the rate of diffusion of the gas. So for Graham's law of diffusion, that we used to teach some of us, we use this. Now you might be asking me, there are about 4 parameters here. How do I apply the law? So assuming you have faced a question and it gives you just rates and time. So every that automatically become 1. So let's say you have a question, you are faced with a question, and the question just has to do with rate and time. What will you do? So it means you have a new formula. So the new formula becomes R1 over R2 is equal to T2 over T1. That is if you are giving rate and time. What if the question gives you rate and volume? Means the rest are taken as 1 and as constant. So for as volume, or the rate and volume to be R1 over R2 equals to V1 over V2. The rest are taken as 1. Now the very common ones are rate and time, rate and molecular mass. Yes, you can convert vapor density to molecular mass. Very simple. Vapor density times 2 is molecular mass. So quickly, for rates and what's it called? For rate and molecular mass. So these two ones will be taken as 1. So R1 over R2 is equal to mm2 over mm1. As simple as that for Graham's law of diffusion. So quickly, I'll dive into my question. I'll check which law is it and how to apply the law. Now the question says, what is the temperature of a gas initially at 17 degrees Celsius? You noted that Celsius is temperature and 12 atm. Atm is one of the units of pressure. So I have temperature and pressure. Let's go for that. If the pressure increases to 36 atm, so you're having the pressure increase to 36 atm, it was 12 and increase. So what will be the temperature if the pressure increases from 12 to 36? So we are working with temperature and pressure 36. So we are working with temperature and pressure. So for temperature and pressure, which of the law is connecting temperature and pressure? That should be Hamilton's law, which says that, so for my solution, Hamilton's law says that P1 over C1 is equals to P2 over T2. Now quickly, applying Hamilton's law, please take note, when solving questions, your temperature should be in Kelvin. The temperature should be in Kelvin. So quickly, even our answers are given in Kelvin. So assuming they were even given in Celsius, you solve in Kelvin, convert it back to Celsius. So quickly, 17 degrees Celsius, let's quickly convert to Kelvin, plus 273, converting our temperature to Kelvin. So from Celsius to Kelvin, so that should be 290 Kelvin. Yes, 290 Kelvin. And if you're assuming this is the first temperature and this is the first pressure, therefore this is going to be the second pressure, and the temperature I'm looking for will be the second temperature. So let's quickly fix in our parameters. So we say P1 as given in the equation initially. So P1 is initial, P2 is final. So initially, so P1 converting it to Celsius, or sorry, P1 is atm, that's the pressure, was 12 atm. 12 atm. Yes, P1 was 12 atm. Then for what's it called? For C1 was 290 Kelvin, which was 17 degrees Celsius. That's 290 Kelvin. Now, and we were given P2. Yes, it increased to 36 atm. Therefore, follow me very well, I am looking for T2. I'm looking for T2. Not forgetting our formula was from Hamilton's law. So we are relating pressure and temperature. So quickly applying it. So what's P1? P1 is 12 over, what's T1? T1 is 290. Now T1 is 290 equal to, T1 is 290. P2, what's P2? 36. Now we're looking for final temperature. Making T2 subject of the formula, we just have T2 equal to, if you check very, very well, T2 will be equals to 290 times 36 over 12. Making T2 subject just by cross multiplying. So T2 and 12 will be together, 290 times 36 will be together. So making T2 subject formula. Doing this with your calculator at home, you have T2 to be 870 Kelvin. 870 Kelvin. This is what Jamb wants us to do. these are the exam will go. So what is the correct option now? The correct option is option B. Now I hope these formulas will be very useful for you. Very useful as you go through your past question and as you prepare for the examination. So these formulas will be very useful for those of us not familiar with gas laws. So for instance, I'll give you a question. Assuming you are giving questions on Boyle's law, for instance, you give a question on Boyle's law to solve, not this law now. You use Hamilton's paper, remember? If you are giving the question on Boyle's law, they might give you a first pressure, they give you a first pressure, they give you first volume, they give you second pressure, you have to calculate for the second volume, as simple as that. They can give you on, what's it called, on Charles' law, first volume, first temperature, you have to calculate for the second temperature, and they will give you second volume. They might even give you second volume and second temperature. Even the first temperature, they ask you to calculate initial volume. Also, joining these TV laws, you can get a new law. It's called the general gas equation. What's the general gas equation? P1 V1 over T1 is equal to P2 V2 over T2. So I call this the general gas equation. General gas equation. So general gas equation, GGE. So this general gas equation, you can combine both laws. If I give you first pressure, first volume, first temperature, they will give you second pressure, maybe at STP, next volume at STP, or the temperature at STP. So they calculate the volume now at STP. Or they might give you the volumes at STP or the initial at STP. Give you the volume, the new pressure if you go to, and the new volume it might have increased to or decreased to, then you calculate the second temperature. So I believe this video is very useful for the first question. More questions are coming, so we'll dive into question 2 immediately. So please stay tuned. Don't forget to subscribe and like the video. God bless you.